Good morning, class. Welcome to the physics online classes for class 9. In the previous classes, we are going through the chapter gravitation, in which we have learned about the some topics. So get through the quick revision of the topics which we have learned, because in this session we are going to learn about the numericals. But in the first session, in the numericals will be regarding to the topic of universal law of gravitation, that is the value of the G or the value of the F. Okay, so we will be seeing the numericals regarding that formula. So first I just recall what we have learned about the gravitation, that it is a force of attraction that is exerted by the earth on any object, and this force is always towards the center of the earth and acts in the downward direction. Okay, and the universal law of gravitation, what we have learned, that the force which is acting on the two objects present on the earth is given by force is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. Right? It was m1 m2 upon r square. And to delete this, or we can say that to vary this proportional sign into the equal sign, we just use a constant which is a proportional constant, and in this numericals we will be using this gravitational constant. So it is g m1 m2 upon r square. The m1 and m2 are the mass of the objects, that two objects mass will be given, and here r shows the distance between that two objects, right? And g is the gravitational constant and f is the gravitational force. Okay, f is the force. Got it? So we will be going through the formula as well as the numericals regarding this formula itself. Then we will be understanding about the acceleration due to gravity, that is a small g. Okay, so see the numericals. The first one, as you can see on the screen, that whenever a gravitational force acts between the two objects, then it just depends on the mass of the two objects. So in this numericals, we are just assuming that there are the two objects which are of 1 kg each, and they are separated from each other with a 1 meter distance, that too from the center. If this is the center of the body, then the distance between the two centers is given by r, which is equals to 1 meter, and the distance should be in the meter. If it is given in kilometer, you just convert it into the meters. Okay, so r value is given, and already the masses are of the both the objects are same, that is 1 kg, and m2 is also 1 kg. So we know that f is equals to g m1 m2 upon r square, that is 6.67 into 10 to the power minus 11. Just remember this value of gravitational constant, but because it will be used in each and every numericals in this chapter. And the other one will be the acceleration due to gravity, that is small g. The value will be 9.8 meter per second square. It will also be used. So just by heart these two values in this chapters. So 6.67 into 10 to the power minus 11, and since it is a product, so we'll be just multiplying the numerator values, and the denominator value is given as a square, so the value of r will be doubled, that is it will be multiplied by the same number again. Now m2 and m1 both are 1 kg, so we'll be writing as 1 into 1, and square of the distance, that is 1 meters whole square, right? So what we can just write it as, because we are multiplying it with 1 and dividing it with 1, so we will get the similar values, right? We will get the similar values. So how can we write it as? Just see, f was equals to 6.67 into 10 to the power minus 11, so it is multiplied to 1, so the same value will be the same, and it's divided by the 1, so its value will also be same. But here we will be not writing it as Newton meter per kg square, because it is the unit for the gravitational constant. But for the gravitational force, it is given by the newtons, because it is a kind of force. So value is similar to that of the gravitational constant itself. Okay, so we can just say that is the value of the gravitational constant is on these two bodies which are of 1 kg each and are kept at apart with a distance of 1 meter, so that the earth attract one another is also the same, and the gravitational force acting on them is constant because it is a value, or according to that gravitational constant the value is same. So we can say that the attraction of force or the gravitational force acting on that two object is very small, and it will not cause any motion because it is a constant value. Okay, see now the next, for the next value, calculate the force of gravitation due to the earth on a ball of 1 kg mass lying on the earth, right? The objects which we are taking now in this sample problem will be two objects, that is earth, one object, that is mass m1 will be earth, this is earth, let it be earth, and here we are taking a ball on the surface of the earth, right? So this ball is given as a mass of 1 kg, so we can write it as m2 is 1 kg and mass m1, that is earth's mass, will be 6 into 10 to the power 24 kg. Okay, that is 6 into 10 to the power 24 kg, and the distance between two objects will be given as, that is distance between the center of the earth and to that object, and if any center to the earth it touches to any point, then it will be the radius of the earth, that is similar to the radius of the earth. So value of r will be equal to the radius of the earth itself, and the radius of the earth is given by 6.4 into 10 to the power 3 kilometers. Okay, so we have already known that the value of the kilometer should be converted into the meters because the distance should be in the meters, right? So we will be just converting that into the meters. How will we be converting? That is 6.4 into 10 to the power 3 kilometers. So again we have to multiply because 1 kilometer is equals to 1000 meters, right? It is given by 1000 meters. So we will be multiplying it with 1000, and 1000 here are the three zeros. So we can write it as 10 to the power 3. So I am multiplying 6.4 into 10 to the power 3 again with the 10 to the power 3. And what this powers will do, we know that whenever the bases are same, the powers are used to be added. So 3 plus 3 will be 6. So it will be given as 6.4 into 10 to the power 6 meters. So it is converted into the meter. So these three values, that is 1 kg and 6 into 10 to the power 24 kg, that is the mass of the second object, and the universal gravitational constant, which is equals to the 6.67 or 7 into 10 to the power minus 11. This all values will be kept in the formula of the universal gravitational law. Then we will be finding the value for the force of the gravitation due to the earth on this object, and the object which we are considering in this numerical is a ball which is kept on the surface of the earth, which is of mass 1 kg. So we will just see the gravitational force acting on this object due to the earth. Okay, so you can see on the screen these three values, that is the mass m1, that is the mass of the earth, is given by 6 into 10 to the power 24 kg, and the mass of the the second object is ball, so the mass of the ball is given by 1 kg, and the force formula, which is given by g into m1 m2 upon r square, where g is the gravitational constant and the value of the gravitational constant g is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So on just keeping these values in the formula, what we will derive, see here we have changed the value of the kilometers into the meters, so we will just value will be kept in the formula, that is 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 kg, that is the mass of the first object, and the mass of the second object is 1. And after that, the distance of the square, that is square of the distance, will be 6.4 into 10 to the power 6 and its whole square. Okay, so the 10 values will be solved first. So just solve the power values first, which is given as 6.7, let it be like the same. Now again 6 is there, so it will be the same, and at the down it will be 6.4 into 6.4. Okay, and here the 10 to the power minus 11 and 24 will be given as 10 to the power 13, let it be. And at the down the powers used to be what it does, 6 into 2, that is a multiplied. If there is a power outside the bracket, then the inside the power 1 and the outside the power 1 will be multiplied to each other, then it will be 12. And the bases are same. If it is kept in the divide form, then the powers will be subtracted to each other, so it will be given as 13 minus 12, which can be given as a 13 minus 12, it will be 1. So what can we write here? Only 10 to the power 1. And now we just have to multiply 6.7 into 6, it is given by 40.2. Okay, so again we will be using the 10 also, and at the down it is 6.4 into 6.4, it is given by 40, the 6.4 into 6.4, that is 40.96. Okay, so we will be dividing this 40.96 and 40.2, that is 40.2 divide 40.96, and it is given by 0.988, and here the 10 is here. Okay, so on just doing this numericals, we will be shifting the decimal towards the first digit, because the decimal in the standard form should be after the first digit, so it will be written as 9.8. Okay, and during writing this the power will be decreased, so the 10 to the power 1 is here because only one 10 is here. So if we are subtracting 1 from the 1, then it will be 0, then it will be 10 to the power 0, that is 1. So the answer will be only 9.8. So we can write it as 9.8 newtons, because we are finding the gravitational force, that is force, it will be given as the newton. So here you can see F is equals to 9.8 newtons, which we can say that the earth exerts a gravitational force of 9.8 newton on that object, that is the ball. Okay, the object 1 kg ball, whenever the force it is, whenever it is dropped or when it is moved to the vertically upward direction, it will come towards the center of the earth, that is the gravitation will be acting on that object. So that object is just exerting the force on the ball will be of 9.8 newtons, that is comparatively a large force. So whenever a body is on the earth's surface, it will, if it is of 1 kg mass, then the force acting on it will be of 9.8 newtons. Got it? So just see the next problem. Okay, so before going to the numericals, we will see here some values of the masses of the sun, earth and the moon. So from the figure we can see that the value of the mass of the sun is 2 into 10 to the power 30 kgs. What does it mean? That after the 2 there will be 30 zeros. So what we can say, that it is a large value, that is the mass of the sun is too large. And after the mass of the earth, after the sun, we will be seeing the mass of the earth. What it is written there, 6 into 10 to the power 24 kgs. What it does mean? That it is equal to the value of 6, and after that there will be 24 zeros, and it is in the kg. Right? Now next, the mass of the moon, which is given by 7.4 into 10 to the power 22 kgs. That is, after 74 there will be 21 zeros, because already it is point. If we are talking about the 74, then it will be 21 zeros. So what we can say, that the masses of the sun, earth and moon are extremely large. So the gravitational force between the sun and the earth will also be more, because it depends on the mass. Right? We have learned that the force depends on the product of the masses. So these masses are too large, because we are using 10 to the power 30 and 10 to the power 24. So the product of these zeros will be also a large value. So the gravitational force value will also be large. So we can say that the large gravitational force will be acting between the sun and the earth, as well as on the moon in the earth also. Okay, so next see the, because you just have to remember these values, for that you just remember the mass of the earth and the mass of the moon, because we don't have to solve the numericals for the sun. But if it is given, then in the numerical itself the values will be given, so you don't have to be tensed about that to remember how to by heart these values. But just remember the earth's radius and earth's mass, that is 6 into 10 to the power 24 kg, that is the mass of the earth, and the radius of the earth is given by 6.4 into 10 to the power 3 kilometers. Okay, so just see the next problem, what it is given here in the question. Just understand the question first, that what we have to find, because here we are seeing the one numerical itself, that is from the gravitation chapter. So we can easily tell that which the formula is. But if you are getting into the exam and there will be together 2 chapters, 3 chapters will be together, right? So we just have to determine how the numerical is and from which chapter it is given, and what will be the formulas that will be used for this numerical. So you just have to determine the question, that what are the values which are given and what are the values which we have to find. So what it is written here, the mass of the earth is 6 into 10 to the power 24 kg, right? And the mass of the moon is 7.4 into 10 to the power 22 kg. Then The distance between the earth and the moon is 3.84 into 10 to the power 5 kilometers. We have already told you that the mass should be in the kg, and here the mass is given in the kg itself. But the distance between the two objects should be in the form of the meter. But here the distance is given in the kilometers. So we will be just changing it into the meter also. And just calculate the force exerted by the earth due to that moon. Okay, exerted by the earth on that moon. So it is gravitational constant. We already know the value because 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, so we will be using this in the numerical. We know that G is the value 6.67 into 10 to the power many minus 11. So in many numericals you will be using 6.7 also. So no mistake over there, because it is somewhat approximately it is given as 6.67 will be given as 6.7. Okay. Now the G m1 m2. So mass 1, that is the mass of the earth, that is 6 into 10 to the power 24 kgs. And the mass of the moon is given by 7.4 into 10 to the power 22 kg, and it is divided by the distance of the square between them. The square of the distance means 3.84, as well as is given as 10 to the power 5 kilometers. If we are changing into meter, then we have to multiply it with 1000, that is 10 to the power 3. So together it will be 10 to the power 8. So it will be 10 to the power 8 and the whole square of that whole number. Okay. So how you will be solving it? First of all, just open the bracket, that is the whole square, so that you will be multiplying the number twice to that number itself, and just clear the values of the 10, that is you will solve the power to the 10 values first, then you will be solving the numerical values. That is 6.7 was the value of the gravitational constant. Now the m1, that was 6 into 10 to the power 24 kg, and the next, that is 7.4 into 10 to the power 22. So what are the tens value which are left over here? That is 24 minus 11 and 22. So what will be the value? The values which are given in the positive will be added together. So 24 plus 22, it will be 46, and 46 minus 11, it will be 35. And the denominator, it was 3.84, right? We have to multiply it twice. So 3.84 into 3.84, and this 10 to the power 8, right? 10 to the power 8 meters, because we have converted the 10 to the power 5 kilometers into the meters, so it will be 10 to the power 8 meters. And this 10 to the power 8 meters, if it is square, then it will be 10 to the power 16. And this 10 to the power 16 will move to the numerical, then it will be subtracted to the value of the 10 which was given earlier. And the value of 10 which was given earlier was 10 to the power 24 minus 11, it was 13, and after 13 plus 22, it was 35. So what we can write, that 35 minus 16, it is something 29. Sorry, 19 only. It will be 19. Okay, 10 to the power 19. And we just have to multiply 6.67 upon 3.84 into 3.84. You just have to multiply 6.7 first, then you just have to multiply 3.84 together, then you can just write the values, and then you can divide. That is 6.7 into 6.7. We have already multiplied in the first numerical also together. That's 6.7 into 6.7 into 6, and then 7.4. Sorry, 6.7 into 7.4 into 6. It is given by 6.7, that is multiplied to 6, and again it is multiplied to 7.4. It is given by 297.48. Okay, and again we are having 3.84 into 3.84, because it was square, so we have to multiply that number twice, which was given by 14.74. Now we have to divide it, so just go through the approx value, that is 14. This is 29. So what we will be using? 14 twos are 28. What is the remainder over there? 1. That will be 17. So 14's value will be not seen here, so it will be taken as 0. Okay, so we will be just approximating the values. You can divide it, and you can understand that what the value it will be started from, right? So on dividing this, we will get the value of 20.18. That is 20.18. But here we are having the value of 10 to the power 10 to the power 22. 9 also, that is 19 also, sorry, as 19 also. Now we are just have to move that decimal towards the first value, because we have to write it in the standard form. So we just have to write the decimal after the first letter itself, after the first number. So we can write it as 2 point. Okay, then we have written there the 20.18, right? So here we will be writing as 2.018, and after that the point was 19, so it will be increasing into the 20. So the answer is 2.01 to 10 to the power 20 newtons. Okay, got it? This were the numericals which we have seen in this session regarding the gravitational force, gravitational constant, and the mass of the object and the distance between these two objects, in which we have seen the mass of the earth also, mass of the moon also, and the radius of the earth also, because if any object is kept at the surface, then the distance of that object toward the center of the earth will be the radius of the earth, which was given as 6.4 into 10 to the power 3 kilometers. So what we can say, that the radius of the earth is also used here, mass of the earth is also used here. So you can just go through the values which were given in the textbook, you have seen in this video also. So if you have any doubts regarding this numericals, you can ask me. And because in the next session we will be seeing the numericals which will use a gravitational acceleration, that is small g's value will be used, that was 9.8. And in the last session you have read about the equations of the motion for the freely falling bodies. So this particular point, this 5 points and the values of the 3 equations will be used, but the numericals will be seen in the next session. So just seeing these videos, again try the numericals and again solve by your own, so that you can by heart the numericals by your, okay, so that you can be get fluent in the solving of numericals. So thank you for this class. In the next class we will be learning about the numericals related to the gravitational acceleration. Thank you.